kept exactly the same as requested. Inductive and deductive methods of teaching. 1. Inductive method. Definition. The inductive method is a bottom-up approach where students are first presented with examples or activities. From these, they observe patterns and then derive the rule, concept, or principle themselves. Word origin, inductive, comes from the Latin word inducere, meaning to lead into. Types of inductive method: observation-based learning, experimentation, discovery learning, inquiry method. Steps of inductive teaching. 1. Present specific examples or data. 2. Students observe and identify patterns. 3. Students formulate a general rule or principle. 4. Teacher confirms or refines the rule. Students apply the rule to new situations or problems. Role of the teacher: acts as a facilitator or guide, provides carefully selected examples, encourages student thinking and participation. Role of the student: actively observes, analyzes, and discovers rules, participates in discussions, and draws conclusions. Advantages of inductive method: promotes critical thinking and discovery, builds conceptual understanding, increases student engagement, encourages active learning. Disadvantages of inductive method: can be time-consuming, may be challenging for slower learners without support, students may draw incorrect conclusions without proper guidance. 2. Deductive method. Definition. The deductive method is a top-down approach where the teacher begins by explaining a rule or formula, followed by examples and practice exercises. Word origin: deductive comes from the Latin word deducere, meaning to lead down or derive. Types of deductive method: rule example method, lecture method, direct instruction, formula first teaching. Steps of deductive teaching. 1. Teacher introduces the rule or concept. 2. Provides explanation with examples. 3. Students apply the rule through exercises. 4. Teacher provides feedback or corrections. Role of the teacher: acts as an instructor or knowledge giver, clearly presents rules and concepts, oversees student practice and correction. Role of the student: listens and learns information, applies rules and exercises, often takes a passive learning role. Advantages of deductive teaching: time efficient, suitable for larger classes or limited teaching time, effective for memorization and rapid learning, useful for teaching abstract or complex concepts. Disadvantages of deductive teaching: less student involvement, may not foster deep understanding, higher risk of rote learning. Comparison table: inductive method, deductive method. Approach: a bottom-up, top-down, rule, examples. Role of teacher: facilitator, instructor. Role of student: active discoverer, passive receiver. Best for: concept understanding, quick learning and practice. More, less. Thinking skills: develops higher order thinking, emphasizes application. Let me know if you'd like this turned into a PowerPoint or PDF. Thanks, Cameron. Here's your content on dogmatic approach in mathematics and lecture method in teaching, formatted cleanly and unchanged, exactly as you asked. Dogmatic approach in mathematics. What is a dogmatic approach? The dogmatic approach in teaching mathematics is a rigid, rule-based method where instruction is centered on memorization and the strict application of formulas. The teacher provides all information, and students are expected to follow procedures without questioning or exploring underlying concepts. Key features of the dogmatic approach: fixed curriculum. Content remains constant regardless of student needs or interests. Teacher-centered instruction. The teacher leads all activities. Students passively receive information. Emphasis on rote learning. Students memorize steps and formulas without necessarily understanding them. Lack of critical thinking. Learners are not encouraged to ask questions or understand the why behind procedures. Discouragement of inquiry. Students are not expected to challenge ideas or seek alternative methods. Procedure and problem solving using the dogmatic approach. 1. The teacher presents a clearly defined problem. 2. Students recall and state the relevant rule or formula. 3. The formula is applied through substitution. 4. The expression is simplified step by step. 5. The final answer is written down and sometimes verified by substituting it back into the original problem. Advantages of the dogmatic approach. Simplicity. Easy to implement, especially for beginners. Efficiency. Quick problem solving through established steps. Confidence boosting. Students gain confidence from achieving correct answers using known methods. Accuracy encourages precision in the application of mathematical rules. Disadvantages of the dogmatic approach. Lack of deep understanding. Students may not grasp why formulas work. Poor critical thinking development. Limited opportunities to analyze, explore, or create new methods. Restricted problem-solving ability. Not suitable for non-routine or real-world problems. Over-reliance on memorization. Students may struggle if they forget procedural steps. Effects on learners. May lead to disinterest or disengagement. Can increase anxiety or fear of making mistakes. Suppresses creativity and independent thinking. May result in surface-level learning rather than true comprehension. Better alternatives to dogmatic teaching. Student-centered learning. Engages learners through activities and collaboration. Inquiry-based learning. Encourages exploration, questioning, and discovery. Flexible curriculum design. Adapts content based on student progress and interests. Focus on critical thinking. Helps students develop reasoning and problem-solving skills. Conclusion. The dogmatic approach is effective for introducing basic mathematical procedures and ensuring quick, accurate results. However, on its own, it does not promote deep understanding or the development of higher-order thinking skills. To foster meaningful learning, it should be balanced with more interactive and inquiry-driven teaching strategies that empower students to think critically and apply their knowledge in diverse contexts. Lecture method in teaching. Definition. The lecture method is a traditional teaching technique where the teacher delivers content directly to students, usually through verbal explanation. It is a teacher-centered approach where students listen, take notes, and absorb information. Origin. The lecture method dates back to ancient Greece, where philosophers like Socrates, Plato, and Aristotle shared knowledge through spoken word. It has remained popular in schools, colleges, and universities for centuries due to its simplicity and efficiency. Types of lecture method. 1. Formal lecture. Teacher delivers content without interruption. No student interaction during the session. 2. Informal lecture. Teacher includes some student interaction or discussion, encourages questions and feedback. 3. Illustrated lecture. Uses visual aids, charts, models, slides to explain topics. 4. Demonstration lecture. Combines explanation with practical demonstrations, commonly in science or math. Steps in the lecture method. 1. Preparation. Teacher plans and organizes content. 2. Introduction. Begins with a brief overview or question to grab attention. 3. Presentation. Delivers the main content with examples and explanation. 4. Illustration optional. Uses diagrams, pictures, or real-life examples. 5. Summary. Reviews key points of the lecture. 6. Assessment optional. Asks questions to check understanding. Role of the teacher in the lecture method acts as the main source of knowledge, organizes and delivers content clearly, manages time and keeps students focused, may use visuals or real-life examples, answers questions, if allowed, in the lecture type. Role of the students in the lecture method. Listen actively and take notes. Follow the teacher's explanation. Ask questions in informal or interactive lectures. Stay focused and respectful. Review notes after the lecture. Advantages of the lecture method. 1. Covers large content quickly. 2. Useful for large groups of students. 3. Cost-effective, no need for extra materials. 4. Helps in explaining theoretical and abstract concepts. 5. Easy to plan and organize. Disadvantages of the lecture method. 1. Passive learning, students just listen. 2. Limited interaction and engagement. 3. May not suit all learning styles. 4. Hard to maintain attention for long. 5. Little opportunity for practical or hands-on learning. Conclusion. The lecture method is a simple and traditional way of teaching, effective for delivering theoretical knowledge. However, to make it more engaging, teachers should combine it with discussions, visual aids, and interactive elements. Let me know if you want all of this compiled into a PDF or PowerPoint. Thanks, Cameron. Here's your requested content on the analytical method and synthetic method of teaching mathematics, presented in a neat, structured format, unchanged, just clean and easy to read. Analytical method. Introduction. The word analytical comes from analysis, which means breaking something into parts. In the analytical method, a problem is broken down into smaller parts to understand and solve it. It helps uncover hidden aspects of the problem. Approach. It moves from unknown to known, solves problems from complex to simple. It is a learner-centered method, focusing on the student's thinking process. Example. Solving a math problem by breaking it step by step to understand each part before finding the final answer. Merits, advantages. Encourages active participation, helps students clearly understand the topic, promotes learning by doing, improves thinking and reasoning skills, builds self-confidence. Demerits, disadvantages. It is a lengthy and time-consuming method, not suitable for all age groups, not effective at early stages of learning math. # synthetic method of teaching mathematics. Definition. The synthetic method in mathematics involves combining known facts or data to understand and solve unknown problems. It follows the approach of moving from the known to the unknown, focusing on building solutions systematically by connecting various facts and operations. Merits of synthetic method. 1. Time and labor saving. Reduces the effort needed to teach and learn complex concepts. 2. Efficiency. Concise method that covers most topics efficiently. 3. Systematic presentation. Organized and clear delivery of facts and concepts. 4. Child-centered approach. Learning moves from familiar to unfamiliar concepts. 5. Accuracy. Helps in developing accurate reasoning and solutions. Demerits of synthetic method. 1. Forgetting. Relies on memorization, leading to possible forgetfulness. 2. Passive learning. May encourage cramming and reduce engagement. 3. Increased doubt. Lack of deep understanding can lead to confusion. 4. Lack of confidence. Learners may struggle to apply knowledge independently. 5. Recall issues. Difficulty in recalling steps may hinder understanding. Difference between analytic and synthetic methods. Analytic method, synthetic method. Direction. Breaks down complex ideas into simpler elements, builds up from simpler elements to form a whole. Moves from the unknown to the known, moves from the known to the unknown. Approach, discovery-based exploration, presentation of already discovered facts. Nature, a thinking and exploratory process, a product of thought focusing on conclusions. Length, longer, more detailed and laborious. Shorter, more concise. Conclusion. The synthetic method is effective for quickly covering mathematical topics and building accuracy in solving problems. However, it can lead to passive learning and difficulty in retaining and applying knowledge if not supported by active engagement and understanding. Let me know if you'd like these topics compiled into a study guide, PowerPoint, or printable PDF. I'm happy to. Thanks, Cameron. Here's your content on the heuristic method and project method of teaching mathematics, neatly formatted without changing any content, just cleaned up for readability and presentation. Heuristic method of teaching mathematics. Introduction. The heuristic method focuses on problem solving and self-discovery. It encourages students to find solutions through their own exploration and thinking, rather than relying on teacher-led explanations. The term heuristic comes from the Greek word meaning I find or I discover. This method is based on trial and error, promoting logical and imaginative thinking. Aims of heuristic method: 1. Scientific attitude. Enables students to solve problems using Thanks, Cameron. Here's your content on the heuristic method and project method of teaching mathematics, neatly formatted without changing any content, just cleaned up for readability and presentation. Heuristic method of teaching mathematics. Introduction. The heuristic method focuses on problem solving and self-discovery. It encourages students to find solutions through their own exploration and thinking, rather than relying on teacher-led explanations. The term heuristic comes from the Greek word meaning I find or I discover. This method is based on trial and error, promoting logical and imaginative thinking. Aims of Sure, here's your complete content on the heuristic method of teaching mathematics, preserved exactly as you wrote it with no changes. Heuristic method of teaching mathematics. Introduction. The heuristic method focuses on problem solving and self-discovery. It encourages students to find solutions through their own exploration and thinking, rather than relying on teacher-led explanations. The term heuristic comes from the Greek word meaning I find or I discover. This method is based on trial and error, promoting logical and imaginative thinking. Aims of heuristic method. Scientific attitude enables students to solve problems using a scientific approach. Independent thinking fosters the ability to think independently and critically. Knowledge acquisition helps in acquiring new concepts through self-discovery. Data collection and analysis encourages students to collect and analyze information to solve problems. What is heuristic method? In this method, students act as independent discoverers. The teacher sets the problem and then steps back, allowing students to find the solution using various resources like libraries, internet, or experiments. Students engage in creative thinking, utilizing their logical and imaginative powers to solve problems without direct guidance from the teacher. Procedure of heuristic method. 1. Problem presentation. A problem is presented to the students without detailed instructions. 2. Independent discovery. Students conduct experiments, use available resources, e.g., books, internet, and figure out the solution on their own. 3. Documentation. Students record their observations, process, and results. 4. Conclusion. Students draw conclusions based on their findings, refining their understanding of the problem. Objectives of heuristic method. Problem solving. Helps students solve problems using a scientific attitude. Independent thinking. Encourages students to think independently and logically. Demonstration and explanation. Students demonstrate their findings and explain their reasoning. Holistic development. Promotes cognitive, affective, and psychomotor development in students. Principles of heuristic method. Principle of freedom. Students have the freedom to explore and solve problems on their own. Principle of thinking. Encourages critical and independent thinking. Principle of activity. Learning is achieved through active participation. Principle of self-study. Students take responsibility for their learning process. Principle of purposeful experience. Learning is based on meaningful and goal-oriented experiences. Merits of heuristic method. Active learning. Students learn by doing, solving problems themselves. Holistic development. Encourages growth in cognitive, emotional, and physical areas. Scientific attitude develops a scientific mindset in students. Independence. Students become self-reliant in their learning. Personalized attention. Teachers can provide individualized guidance to students. Demerits of heuristic method. Time-consuming. The method requires significant time for students to explore and find solutions. Impractical for all students. Not all students may be able to work independently, especially those who need more guidance. Extra work for teachers. Teachers must prepare problems and be ready to guide students individually. Costly. It may require additional resources or tools for experiments and exploration. Role of teacher in heuristic method. Encourager. The teacher encourages students to explore and discover solutions independently. Facilitator. While the teacher steps back, they provide guidance as needed and ensure students stay on track. Individual support. The teacher provides personalized help to each student, creating a supportive learning environment. Conclusion. The heuristic method is about moving away from traditional spoon feeding. It provides opportunities for students to explore, think critically, and work independently, enhancing their problem-solving skills and fostering a deeper understanding of concepts. This method helps create a dynamic, inquiry-driven learning environment. Method. Concept of project method. The project method is a teaching approach that was introduced in the 18th century, originally in architecture and engineering schools in Europe. It involves applying skills and knowledge to solve practical problems. John Dewey's philosophy of pragmatism influenced its development, and William Herd Kilpatrick expanded it into an educational philosophy focusing on child-centered progressive education. Definition of project method. Stevenson. A project method is a problematic act carried to completion in its natural setting. A project is a wholehearted, purposeful activity proceeding in a social environment. A project is a bit of real life that has been imparted into the school. Principles of project method. Principle of purpose. Every project must have a clear purpose and goal. Principle of activity. Learning happens through active participation and doing. Mentally and physically engaging activities. Principle of experience. The method involves seeing, experiencing, and learning from real-life situations. Principle of reality. Projects should involve real-world tasks, circumstances, and practical knowledge. Principle of freedom. Students should be given the freedom to choose and direct their projects. Principle of correlation. Subjects should be interconnected, showing relevance in real-world contexts. Principle of sociability. Activities should involve cooperation, social responsibility, and helping others. Types of project method. General kind of project method. Simple projects, single task projects, e.g. cooking. Complex projects, multitask projects, e.g. stage drama. Specific kind of project method. Literary products, projects related to literature. Historical and biographical projects, projects based on history or biographies. Technical projects, projects related to technical skills. Scientific projects involving experiments and research. Industrial and commercial projects related to industries and commerce. Stages of project method. 1. To provide situation, prepare students mentally for the project. 2. To choose project, students select their own projects based on interest. 3. To plan, students create a plan for the project. 4. To execute, students carry out the project with teacher assistance. 5. To evaluate, students assess their own work with final evaluation from the teacher. 6. To make record, the process and results are recorded and the teacher monitors progress. Merits of project method. Based on laws of learning, aligns with the principles of learning. Best learning conditions, encourages active and engaged learning. Develops various skills, fosters initiative, social skills, critical thinking, and planning. Real-life application provides learning experiences in real-life situations. Cooperative and group interaction encourages teamwork and social habits. Demerits of project method. Learning can be accidental, may lack structure or continuity in learning, does not cover entire curriculum, some curriculum areas may be neglected, limited resources, lack of suitable books or materials. Requires skilled teachers. Effective project-based learning needs trained and experienced educators. Time and material intensive. Projects can require a lot of time and resources. Conclusion. The project method is a student-centered and active learning approach that has its strengths in fostering real-world connections and critical thinking, but it also has challenges regarding resources, structure, and teacher expertise. Definition. The problem-solving method is a student-centered teaching approach where learners are given a problem or challenge to solve using their thinking, logic, and previous knowledge. It encourages active learning, critical thinking, and independent exploration. Origin. The method has roots in the ideas of John Dewey, a famous educationist and philosopher from the early 20th century. Dewey believed learning should be based on real-life problems, not just memorizing facts. Types of problem-solving methods. 1. Inductive problem-solving. Students observe examples and discover rules or formulas. 2. Deductive problem-solving. Students apply already known rules to solve problems. 3. Inquiry-based problem-solving. Students ask questions and research to solve open-ended problems. 4. Heuristic method. Trial and error method, where students try different approaches to find the best solution. Steps in the problem-solving method. 1. Identify the problem. Clearly state the problem that needs to be solved. 2. Understand the problem. Analyze and discuss what is known and unknown. 3. Formulate a plan. Choose a suitable strategy or formula to solve the problem. 4. Execute the plan. Apply the chosen strategy and perform calculations or experiments. 5. Check the results. Review and verify if the solution is correct. 6. Reflect. Discuss what was learned and how it can be applied to other problems. Role of the teacher: acts as a facilitator or guide, presents the problem clearly, encourages students to think independently, provides support without giving direct answers, helps students reflect on their solutions. Role of the students: take active part in solving the problem, discuss and share ideas in groups, use their logic, knowledge, and creativity, evaluate and reflect on their own learning, ask questions and search for solutions. Advantages: 1. Develops critical thinking and reasoning skills. 2. Encourages independent learning. 3. Improves confidence and creativity. 4. Makes learning practical and real-life based. 5. Enhances communication and teamwork if done in groups. Disadvantages: 1. Time-consuming. Takes longer than traditional teaching. 2. Some students may feel confused or lost without direct instruction. 3. Requires skilled teachers to guide effectively. 4. May not be suitable for every topic or concept. 5. Hard to manage with large class sizes. Conclusion: the problem-solving method helps students learn by doing. It's excellent for building real-world skills, promoting active participation, and deep understanding of concepts. When guided properly, it can turn students into independent and lifelong learners. Let me know if you need this content in a different format or want to add any. Here's the content you shared, formatted as requested without any changes. Types of work in mathematics. Purpose: to build problem-solving skills and apply math in real-life situations. 1. Oral work. Definition: talking about math ideas, concepts, or solutions out loud. Example: class discussion on fractions where students share their thoughts. Advantages: builds communication skills, improves critical thinking, encourages teamwork. Disadvantages: may be hard for shy students, takes more time. Daily life uses: students argue for or against math-related ideas, math presentations, explaining a concept to the class, math discussions, sharing thoughts on how math is used in life, math role plays, acting out math-related roles like a cashier or financial advisor. Written work. Definition: writing down math problems, solutions, and explanations. Example: solving algebra questions in a homework notebook. Advantages: sharpens problem-solving and thinking, records student learning. Disadvantages: time-consuming, can feel boring to some students. Daily life uses: completing math worksheets, solving problems using formulas, making graphs, charts, and tables, writing math journal entries. Assigned work. Definition: math tasks given by the teacher to practice what has been taught. Example: solving geometry questions to practice perimeter and area. Advantages: strengthens concepts, helps teachers check student understanding. Disadvantages: can be boring or too much for busy students. Daily life uses: textbook exercises, math worksheets, math projects, test preparation, homework tasks. Project work. Definition: big tasks where students use math to solve real-world problems. Example: calculating the cost of materials for a school project. Advantages: builds real-life math skills, boosts thinking and analysis, makes learning more fun and practical. Disadvantages: takes a lot of time. Daily life uses: designing a house using measurements, budgeting for events, creating math-based games, planning personal finances, solving real-life issues like traffic or energy use. Conclusion: all types of math work, oral, written, assigned, and project work, are important. They help students think better, solve problems, and use math in real life. Mixing these methods makes learning math more fun, deep, and useful. Let me know if you need anything else or any further adjustments. Here's the content you provided, kept exactly as is. TashChat techniques of teaching mathematics. 1. Discussion method. Definition: a teaching technique where students and teachers share ideas and opinions about a math topic. Types: teacher-led discussion, guided by the teacher; student-led discussion, students take the lead; small group discussion, done in small teams; whole class discussion, everyone participates. Role of teacher: starts the discussion with questions, keeps the discussion focused, encourages all students to speak. Role of student: shares ideas and listens to others, asks and answers questions, respects different viewpoints. Advantages: improves understanding and thinking, builds confidence and speaking skills, encourages teamwork. Disadvantages: time-consuming, some students may stay quiet, can go off topic without good control. 2. Group work method. Definition: students work together in small groups to solve math problems or complete tasks. Types: homogeneous groups, same-level students; heterogeneous groups, mixed ability students; task-based groups, created for a specific task, project. Role of teacher: plans the groups and tasks, monitors and supports students, assesses group performance. Role of student: collaborates and helps others, shares responsibility, completes their part of the task. Advantages: builds teamwork and communication, encourages peer learning, makes learning more active. Disadvantages: some students may not contribute. Conflicts can occur in groups, harder to assess individual learning. There are 3. Drill and practice method. Definition: a method where students repeatedly solve similar math problems to build speed and accuracy. Types: oral drill, verbal questioning and quick answers; written drill, worksheets and written exercises; interactive drill, using games or software for practice. Role of teacher: prepares the drills, observes and gives feedback, tracks student improvement. Role of student: repeats exercises, focuses on accuracy and speed, learns through repetition. Advantages: strengthens memory and skills, builds confidence in basic math, improves speed and accuracy. Disadvantages: can be boring or repetitive, focuses on rote learning, not understanding, may not suit creative learners. Conclusion: each teaching technique, discussion, group work, and drill and practice has its own purpose in making math learning effective. Discussion builds thinking and communication. Group work encourages teamwork and peer support. Drill and practice develops mastery and fluency. A good teacher uses all these methods wisely based on the topic and students' needs. Let me know if here's the content you provided, kept exactly as is. Had forms of classroom organization. 1. Whole class work. Definition: the teacher teaches all students together at the same time. When to use: introducing new topics, giving instructions, reviewing content together. Advantages: saves time, everyone gets the same information, builds class unity. Disadvantages: less individual attention, may not suit all learning styles. Large group work. Definition: the class is divided into 2 or more big groups for learning activities. When to use: class debates, solving math problems in teams, group presentations. Advantages: encourages teamwork, easier management than whole class, promotes discussion. Disadvantages: hard to manage noisy groups, some students may stay inactive. Small group work. Definition: students are divided into small groups, 3 to 6 students, to work together. When to use: group projects, peer teaching, solving tasks together. Advantages: increases participation, better peer learning, encourages collaboration. Disadvantages: time-consuming, group conflicts can arise, unequal participation. #4. Individual work. Definition: each student works alone on assignments or tasks. When to use: practice problems, tests and quizzes, independent research. Advanced self-learning promotes self-learning, easy to assess individual progress. Students work at their own pace. Disadvantages: less interaction, may be difficult for struggling students. Conclusion: a balanced use of all these classroom organizations, whole class, large group, small group, and individual work, can create an effective and engaging learning environment. Let me know if you need. Here's the content you provided, kept exactly as is. Skills of teaching mathematics. 4.1. Skill of stimulus variation. Definition: This skill is used to keep students attentive and interested by changing teaching methods and styles during the lesson. Techniques include changing voice tone and pitch, moving around the classroom, using gestures and facial expressions, switching between visual aids, charts, models, boards, asking questions, and using pauses. Advantages: keeps students engaged, prevents boredom, helps in better understanding. Role of teacher: use different teaching styles, keep checking students' attention, use eye contact and movement wisely. Role of students: stay alert and responsive, follow the variation and stay focused. 4.2 Reinforcement skill. Definition: reinforcement means encouraging and strengthening students' correct responses and behaviors. Types: positive reinforcement, praise, rewards, clapping. Negative reinforcement: removing a negative condition when desired behavior occurs. Verbal reinforcement: saying good job, excellent, etc. Nonverbal reinforcement: smiling, nodding, thumbs up. Advantages: builds student confidence, encourages participation, improves classroom behavior. Role of teacher: reinforce immediately after correct response, be consistent and fair, avoid overusing or misusing reinforcement. Respond positively to encouragement, participate actively. Hash 4.3 Skill of demonstration. Definition: the teacher shows or demonstrates a concept using models, experiments, or visual aids. Example in math: demonstrating how to use a geometry box, showing 3D shapes, or measuring angles with a protractor. Advantages: makes abstract concepts concrete, enhances understanding through visual learning, supports different learning styles. Role of teacher: prepare and organize materials, demonstrate step-by-step clearly, involve students in the process. Role of students: observe attentively, ask questions, participate in follow-up activities. Conclusion: mastering these skills helps math teachers make lessons more interactive, engaging, and effective. By using stimulus variation, reinforcement, and demonstration, teachers can reach learners of all levels and improve overall classroom performance. Let me know if you'd like any further modifications. Here's the content you've provided, keeping it exactly as it is. Skill of problem questions. Definition: this skill is about asking thought-provoking questions that require students to think critically and solve problems. Types of problem questions: open-ended questions, e.g., how can we solve this in a different way? Application-based questions, e.g., where would you use this in real life? Reasoning questions, e.g., why do you think this formula works? Advantages: encourages logical thinking, develops problem-solving ability, increases classroom interaction. Role of teacher: ask clear, challenging questions, encourage multiple solutions, give time for thinking. Role of students: think deeply, share their reasoning, listen to others' ideas. 4.5 Lesson planning. Lesson planning is the process of preparing what and how to teach a particular topic effectively in the classroom. Key parts of a lesson plan: objectives, what students will learn, teaching methods and materials, activities and examples, evaluation, questions or tasks to assess learning. Advantages: keeps teaching organized, saves time, helps achieve learning goals. Role of teacher: prepare in advance, choose suitable methods and materials, adjust the plan based on student needs. Role of students: participate actively, follow the planned activities, provide feedback through their responses. 4.6 Place of mathematics in school curriculum. Why mathematics is important in the curriculum. It develops logical and analytical thinking, helps in daily life, budgeting, shopping, measuring, builds a foundation for science, technology, and business, improves problem-solving and decision-making skills. Goals of math in curriculum: understand basic math concepts, apply math to real-life problems, prepare for higher studies and careers, promote accuracy, creativity, and reasoning. Conclusion: mathematics holds a central place in the curriculum due to its importance in both academic growth and everyday life. It supports students in becoming logical thinkers and smart problem solvers. Let me know if you need any adjustments or additional content. Here's the content you've provided, maintaining the structure and formatting. Model of teaching mathematics. Models of teaching in math refer to planned ways of delivering content that help students understand mathematical concepts effectively. Two commonly used models are HARE 5.1 Explicit Teacher Model. Definition: this model focuses on clear and structured instruction. The teacher leads the class step by step. Key features: clear learning objectives, direct explanation of concepts, guided practice with teacher support, immediate feedback and correction. Role of teacher: explains concepts clearly, demonstrates examples, guides practice, and gives feedback. Role of student: listens carefully, follows steps and examples, practices and asks questions. Advantages: easy to understand, good for beginners, reduces confusion. Disadvantages: less student creativity, mostly teacher-centered. NAR 5.2 Path Smoothing Model. Definition: in this model, the teacher gradually reduces support as students become more confident. It's also known as the scaffolding approach. Key features: teacher provides support at first, encourages independent learning over time, focuses on developing understanding and confidence. Role of teacher: offers help in early stages, encourages students to try on their own, adjusts help based on student need. Role of student: learns with support first, takes more responsibility gradually, becomes an independent problem solver. Advantages: builds confidence, promotes independent thinking, adapts to each student's pace. Disadvantages: may take more time, needs careful planning by the teacher. An alternative model. Definition: the alternative model in teaching mathematics presents non-traditional methods of instruction, often focusing on student-centered learning and creative problem solving. Key features: emphasizes exploration and discovery over direct instruction, encourages students to find solutions independently or in groups, focuses on real-world applications and connections to students' lives. Role of teacher: acts as a facilitator rather than a lecturer, guides students through inquiry and problem solving, encourages collaboration and exploration. Role of student: takes an active role in discovering mathematical concepts, works in groups to share ideas and solutions, engages in hands-on learning and real-life problems. Advantages: fosters critical thinking and problem-solving skills, encourages creativity and independence, engages students more deeply in the learning process. Disadvantages: may be less structured, leading to confusion for some students. Requires more planning and preparation by the teacher. May not suit all learning styles, especially those who prefer structured guidance. FES 5.4 Formation and Application of Mathematical Concepts. Formation of mathematical concepts. This refers to the process through which students build an understanding of mathematical ideas and principles. It involves exploration. Students first explore the concept through examples, hands-on activities, or guided questions. Pattern recognition. They identify patterns and connections between numbers, shapes, or operations. Generalization. Students form broader rules or concepts based on their observations and experiences. Application of mathematical concepts. Once a concept is formed, students apply it to solve problems, make predictions, or understand real-life situations. This step includes problem solving, applying concepts to various problems, both theoretical and practical. Real-world use, using math in everyday situations like budgeting, measuring, or analyzing data. Integration, connecting new concepts with previously learned knowledge, strengthening understanding and skill. Role of teacher, supports students in exploring and discovering mathematical concepts, provides varied activities to encourage application in real-world scenarios, ensures that students can apply concepts to new and unfamiliar situations. Role of student, engages actively in exploring and understanding mathematical ideas, uses mathematical concepts to solve practical problems, develops the ability to connect abstract concepts to everyday experiences. Advantages: helps students see the practical value of math, encourages deeper understanding and retention of concepts, enhances problem solving and critical thinking skills. Disadvantages: may take more time to fully understand concepts, Some students may struggle with the abstract nature of the subject, requires more dynamic and engaging teaching methods. Let me know if you need further adjustments or more information. Here's the content you've provided, structured for clarity. 6.1. Importance of teaching aids in mathematics teaching. Teaching aids play a crucial role in enhancing the teaching and learning process in mathematics by visualizing abstract concepts. Mathematical ideas, especially in geometry or algebra, can be difficult to grasp without visual representation. Aids like charts, graphs, or models make these concepts easier to understand, engaging students. Interactive aids like manipulatives, digital tools, and real-world examples make learning more engaging, motivating students to participate actively. Reinforcing learning. Teaching aids help reinforce concepts through repetition and hands-on learning. Catering to diverse learning styles. Some students are visual learners, others auditory or kinesthetic. A variety of teaching aids ensures that all students can learn in a way that suits them best. For mathematics and related topics, kept exactly as you wrote it, formatted clearly for study or presentation use. 6.2. Some important modern teaching aids for mathematics, including computers. Modern teaching aids have revolutionized the way mathematics is taught. Some of the most effective tools include computers and software. Programs like GeoGebra, Desmos, or MATLAB help with graphing, algebraic calculations, and geometry visualizations. Interactive whiteboards. These allow for dynamic presentations, manipulation of graphs, and collaboration. Mathematical apps. Apps like Photomath or Wolfram Alpha help students understand concepts and solve problems. Calculators and graphing calculators. These tools assist students in learning complex calculations, especially useful in higher mathematics. Videos and animations. These can explain concepts visually, making them easier to understand, particularly for complex topics. How to 6.3. How to set up a mathematics laboratory in elementary school. A mathematics laboratory provides a hands-on space for students to explore mathematical concepts through activities and experiments. Here's how to set one up. Space and materials. Allocate a room with sufficient space for students to work in groups. Equip it with basic materials like measuring tapes, protractors, rulers, geometric shapes, and blocks. Tools for exploration. Include tools for graphing, such as graph paper, calculators, and measuring tools. Incorporate technology like computers and projectors for visual demonstrations. Storage. Ensure that materials are organized and easy to access with labeled bins or shelves for different types of equipment. Interactive areas. Create areas where students can manipulate objects to understand concepts like shapes, fractions, or measurements. How to use teaching aids in mathematics laboratory. To maximize the benefits of teaching aids and the mathematics laboratory, the following strategies can be used. Hands-on learning. Allow students to manipulate objects or use computers for interactive learning. For instance, they could use blocks to understand addition or subtraction, or graphing software to visualize equations. Demonstrations. Teachers can use the whiteboard or projector to demonstrate how mathematical tools and resources work. Group work. Encourage collaborative problem solving, where students can use the laboratory resources together to solve real-world math problems. Experiments and investigations. Use the lab for exploring mathematical concepts through experimentation. For example, measuring objects, calculating areas, or exploring geometric transformations. 6.5. Use of low-cost, no-cost materials for teaching mathematics. Teaching mathematics doesn't always require expensive resources. Low-cost or no-cost materials from the classroom or surrounding environment can be used effectively, such as paper, cardboard, and string, used to create geometric shapes, measure distances, or explore symmetry. Rocks and sticks can be used for counting, forming shapes, or studying patterns. Chalk or whiteboard markers, effective for writing equations, drawing graphs, and making calculations. Buttons, beads, or coins, great for teaching counting, fractions, and basic arithmetic. Natural materials, leaves, stones, or seeds can be used for sorting, counting, or measuring. These materials promote creativity, reduce costs, and make learning more accessible. 6.6 Child-centered activities in mathematics, educational trips, preparation of materials. Child-centered activities focus on making learning more interactive and tailored to the student's needs and interests. In mathematics, this approach can include educational trips, visiting local markets to learn about money and budgeting, exploring parks or nature reserves to study shapes, sizes, and measurements, trips to science museums or technology centers to connect math with real-world applications. Preparation of materials. Students can be involved in creating their own learning tools, such as designing math charts, preparing counting tools, or creating simple math games. This activity boosts creativity, engages students, and allows them to take ownership of their learning. Let me know if you want this compiled with your other notes. Here's your content on measuring achievements in mathematics, formatted clearly and presented as it is for easy reference, revision, or presentation. Pesher 7, Measuring Achievements in Mathematics. Effective measurement of students' achievements in mathematics is crucial for understanding their progress, identifying areas for improvement, and guiding instructional decisions. This can be done through various methods, including tests, quizzes, and assessments. Below are some key components of measuring achievements in mathematics. Some are 7.1, Preparation of different types of tests in mathematics. Types of tests in mathematics help assess students' understanding and skills in various areas. These tests can evaluate both basic skills and higher-order thinking. Common types include formative tests, short tests administered during the learning process to monitor progress. Example, a short quiz on multiplication or fractions. Summative tests, administered at the end of a unit or course to evaluate overall student achievement. Example, a final exam covering all topics learned in a semester, such as algebra, geometry, and calculus. Diagnostic tests, used at the start of a topic or course to identify students' prior knowledge and areas of weakness. Example, a pretest on basic arithmetic skills before introducing advanced algebra concepts. Achievement tests, measure students' knowledge and mastery of specific mathematical concepts after instruction. Example, a test on geometry, measuring knowledge of shapes, areas, and angles. Performance-based tests, assess the ability to solve real-world problems and apply mathematical concepts. Example, a project or task requiring students to design a budget or build a model using geometric principles. Test preparation tips. Clarity, ensure questions are clear and aligned with learning objectives. Variety, include a mix of multiple choice, short answer, and problem-solving questions. Fairness, ensure all students have equal opportunity to succeed by testing a range of abilities. DAS 7.2, using tests for diagnostic purpose. Diagnostic tests are used to identify student strengths and weaknesses before or during a learning process. They help teachers understand knowledge gaps, allowing for targeted instruction. Purpose, identify learning difficulties, helps in identifying where students struggle, e.g., specific operations like multiplication or solving equations. Determine misconceptions, diagnoses wrong ideas students might have about mathematical concepts like incorrect methods for solving fractions. Plan interventions, tailor lessons to address gaps in knowledge by providing extra practice or instruction. Example, a diagnostic test on basic arithmetic might show that students need more practice with addition or subtraction before moving on to more advanced topics like multiplication or algebra. 7.3, Interpreting test results. Interpreting test results is essential for understanding students' levels of mastery and guiding future instruction. Here's how to approach this. Steps for interpreting results. Analyze overall performance. Look at the percentage of correct answers. Identify patterns in mistakes. Are there common areas of difficulty? Break down by topic. Identify which topics or skills students performed well on and which they struggled with. Example, if most students performed poorly on algebraic equations but did well on geometry questions, it suggests a need for focused review of algebra. Use rubrics. A rubric can be used for performance-based tasks to provide a more detailed understanding of how students approached a problem. Individual versus group trends. Compare individual student performance against class averages. Identify students who need extra help or enrichment. Action based on results. For underperforming students, provide additional resources or alternative teaching methods to address gaps. For high performers, challenge them with more complex problems or advanced topics. For the whole class, review concepts that were widely misunderstood and provide more practice through drills or exercises. Example, a math test on fractions may show that most students understand how to add fractions but struggle with multiplying them. This would prompt a teacher to revisit the concept of multiplication of fractions, possibly using different teaching aids or techniques. Let me know if you want this added to a full compiled document with your other math teaching notes. Here's the summary of the content you've provided. 8. Planning mathematics learning. Effective planning ensures lessons are organized, learning objectives are clear, and students' needs are met. Proper planning helps educators deliver lessons efficiently, equipping students with necessary skills and knowledge. 8.1. Importance of planning in teaching mathematics. Planning is essential for the following reasons. Clarity and direction. Focuses on learning, formatted exactly as provided for clarity and ease of use in notes, presentations, or study material. 8. Planning mathematics learning. Effective planning ensures lessons are organized, learning objectives are clear, and students' needs are met. Proper planning helps educators deliver lessons efficiently, equipping students with necessary skills and knowledge. 8.1. Importance of planning in teaching mathematics. Planning is essential for the following reasons. Clarity and direction. Focuses on key concepts and ensures all topics are covered. Time management. Ensures lessons progress smoothly and enough time is allocated for each concept. Adaptation. Allows teachers to adjust methods based on student needs and progress. Student engagement. Engages students with varied activities and resources. Assessment and feedback. Allows for formative assessments and timely feedback. Key benefits. Enhances lesson organization. Identifies clear objectives and outcomes. Facilitates diverse teaching methods and resources. Promotes consistent student progress. 8.2. Planning for the full course. Planning for a course involves outlining topics to be covered throughout the semester or year, ensuring a structured approach where students build on foundational knowledge. Steps for full course planning. Identify course objectives. Define student achievements for the course. Determine content areas. Break the course into key topics such as algebra, geometry, calculus, etc. Create a timeline. Plan topic duration and allocate time for each. Incorporate assessments. Plan for quizzes, tests, and projects. Adjust for flexibility. Adapt the plan based on student progress. Example, a one-year course might start with basic arithmetic, moving to algebra, geometry, statistics, and calculus. Each unit builds on the previous one. 8.3. A scheme of work is a structured plan outlining the curriculum for a specific period, e.g., a term or year. It ensures systematic coverage of topics and skills. Components of a scheme of work. Course overview, brief summary of goals and outcomes. Topics units, list of topics to be covered. Teaching strategies, methods and resources for each topic. Assessment methods, plans for quizzes, tests, assignments. Time frame, duration for each topic. Learning objectives, specific skills students should gain from each unit. Lesson planning ensures each class session is well structured and focused on achieving learning outcomes. Steps for lesson planning. Set clear learning objectives. Define what students should learn by the end. Choose teaching methods. Decide on how to present the material, e.g. lecture, group work. Prepare learning resources. Gather materials such as textbooks, charts, and videos. Structure the lesson. Organize into stages. Introduction, development, practice, and conclusion. Plan for assessment. Include ways to assess student learning, such as questioning or exercises. Review and adjust, reflect on lesson effectiveness, and adjust for future use. 8.5. Qualities of a good lesson plan. A good lesson plan should have clear objectives, well-defined learning goals that align with course objectives, engagement, activities that promote student interaction and participation, variety, diverse teaching methods and resources to cater to different learning styles, time management, appropriately allocated time for each part of the lesson, assessment, a way to measure understanding either formally or informally, flexibility, ability to adjust based on class dynamics. Example, a math lesson on fractions may include objectives like simplifying fractions, a real-world example, guided practice, independent practice, and assessment. 8.6. Development of model lesson plans. Model lesson plans act as templates for teachers reflecting best practices and aligning with curriculum goals. Steps for developing model lesson plans. Select a topic. Choose a topic, e.g., solving linear equations. Establish learning objectives. State the outcomes for students. Choose activities and resources. Plan interactive activities and resources, e.g., group work, tech-based learning. Plan assessment methods. Include formative assessments to gauge understanding. Evaluate and reflect. Reflect on the lesson's effectiveness and make adjustments. Let me know if you'd like this added to a complete mathematics teaching methods notes file.